So here we're going to look at how we would use our graphical display calculator to find the equation of a given quadratic curve. So the first thing that's important to note is in order to be able to find the equation of that quadratic, we need to have 3 known coordinates on the quadratic. 2 is not enough. We need 3 known points. And there are 2 methods. The first that I'm going to go through is quadratic regression, and the second is the simultaneous equation solver. Either can be used. It's totally up to you. It's useful to know both. The simultaneous equation solver particularly is useful for many different applications. Okay, so for quadratic regression, the first thing that I'm going to do is I'm going to enter my known data points or my known coordinates in a spreadsheet. And we're going to open a new spreadsheet. These are going to be my x coordinates, and these are going to be my y coordinates. Now, pick coordinates that you know for certain. So in this case, I've got the coordinates -4, 0 that the curve goes through, 2, 0, and 0, -12. So my x value, I've got -4 and 0. I've got 2 and 0. And then I had -12 is my y value. Be careful to get these the right way round. And my x value at -12 is 0. Okay, the next thing I'm going to do is plot a scatter plot with this data. So I'm going to hit Control, add a new page, and add data and statistics. The most common step that people forget is to add their correct variables to the axes. So this will be my x-axis, and this will be my y-axis. And check, this looks sensible for the data, the graph that we have on the left. Okay, so to find the equation of this graph, I go to Menu, Analyze, Regression, and Show Quadratic. And you can see down here, and if you can't see it clearly, you can drag and move that. It has the equation of that quadratic curve, y equals 1.5x squared plus 3x plus -12. By default, your calculator formatting will always have a plus sign, and then if it's a negative number, have minus sign. Obviously, when you're writing the function of that curve, you just need to include it like it is here on the left. So you don't need to write the plus sign. F of x is equal to 1.5x squared plus 3x minus 12.
So now we're going to look at the second method. So that's using the simultaneous equation solver. The first thing that I'm going to do, the simultaneous equation solver requires us to set up some simultaneous equations first before we use the calculator. So I'm just going to jot down the coordinates that we established were on our curve. So we've got -4, 0, 2, 0, and 0, -12. Now, we want to get an equation for our curve in the form f of x is equal to ax squared plus bx plus c. And I know we just did the quadratic regression to get the answer in purple, but let's pretend that we hadn't done that and see if we still get the same result. So this equation, f of x is equal to ax squared plus bx plus c, when we have that for our particular curve and we have our known parameters, so our known values of a, b, and c, and they're constant, what that equation will mean is if we substitute in any point on that curve, so any x value, if we substituted it into our equation, it would give us the y value as the result. So that holds true for every single point on that curve. So I'm going to substitute in, first of all, our first coordinate, -4 and 0. I'm going to substitute in 0 as my y coordinate, so that's on the left. And that's equal to, well, we don't know what a is, but we know that x is -4, that's squared, plus, we don't know b, plus c. And if I simplify this a little bit, I get 16a minus 4b plus c is equal to 0. Okay, I'm going to call that equation 1. I'm going to do the exact same thing with my second set of coordinates. So my second set of coordinates, my y value is also 0, but this time my x value is 2. So I still don't know a, but I'm substituting x for 2. And I can tidy that up a little bit too. And finally, I'm going to do the same thing for my last set of coordinates. For this set of coordinates, my y value is -12 and my x value is 0. So a times 0, b times 0 plus c. Well, anything times 0 is 0, so that just becomes that c is equal to -12. And that's effectively my third equation, although I've already solved for c. So now I'm going to use the simultaneous equation solver on my calculator to find the values of a and b.
So now we have three simultaneous equations set up, equation 1, equation 2, equation 3. Each equation came from substituting in one of those sets of coordinates. And I'm going to use the simultaneous equation solver on my calculator to find the values of a, b, and c. I know that we already know the value of c, but I'm going to pretend we had an equation here and we didn't know that c was -12. So in my calculator, I'm going to go to Menu, Algebra, Solve System of Linear Equations. Your calculator will ask you how many equations you have. So I've got 3. You can do this for any number of simultaneous equations. And it will ask you what the variables are. Now, automatically, it tells you X, Y, and Z. If you want to change it to A, B, and C, that's absolutely fine, and you can do that. You hit OK, and it will include the linsolve function. And what you need to do here is input the equations that you have. So my first equation over here is 0 is equal to 16a minus 4b plus c. My second equation, 0 is equal to 4a plus 2b plus c. And my third equation, which I know is not really an equation, -12, is equal to c. I could have input just 2 simultaneous equations and substituted in -12 for the value of c and use the exact same method. When I hit enter, my calculator will return 3 values. So 3/2 or 1.5 is the value of a, 3 is the value of b, and -12 is the value of c. It will return them in the same order that it's written here. And we can check, does that make sense? If I were to substitute them back into this form, this general form of my quadratic equation, a is 1.5 or 3/2. That's what we got previously. B is +3, as we got previously, and C is -12.